Assalamualaikum and hi. I am Muhammad Iqbal Afiq bin Muhammad. Metric number is AE1944. So, we are from Group 9, Section 1. So, for today, we will present about our group assignment. So, for the first, we go to the group member. Okay, so for the first, we go to the question 1, which is A. So the instruction for A, we need to find the mean, standard deviation, minimum and maximum value for the independent and dependent variable for the data. So for the first, we go to the mean. So mean for age and strengths are here. So for age, we get 40.81 days, while for strength, we get 34.059 megapascal. Next, we go to standard deviation. So by using software, we get age is 50.83658, while for strength, we get 13.86911.535 megapascal. And for the last, we go to the minimum and the maximum value for independent and dependent variable. So for independent, which is age, we have the minimum value is 3, while for maximum value is 365. Next, we go to the dependent for strength. So the minimum value for strength is 4.9, while for maximum value is 71.3. So next, we will go to the further instruction for this project, which is we need to sketch the scatter diagram and regression line for the data. So here we can see the scatter diagram that we plot from the 100 data sets. So by using the scatter diagram, we will make the regression line for the data. Diagram 4.22 shows the linear relationship diagram of the sample of the data.
Assalamualaikum warahmatullahi wabarakatuh, and hello, my name is Muhammad Rafiz Mazugifli with metric ID 8E190016. So next I will cover about the question number C, which consists to find the simple linear regression model using the least square method. So by using the Excel simulation, we can determine the intercept point and the slope value. So from this we can know the equation for the straight line formula, which is y equal to mx plus c. So we just insert the value for slope and c, so we get this equation, which is y equal to 0.09838x plus 30.0733. So this is the linear relationship diagram, straight line diagram. We intercept at 30. So next we go for the question D. So the significant alpha equal to 0.05. So based on the table 4.2.5, the significant in this project is 0.0025. So from this value, we can know that it is less than 0.05. So which means this is there is the hypothesis for this condition, which means the linear relationship between strength and age measure. So we go for the next equation. What is the intercept and slope? So in this project, the slope of the line represents the steepness, while the intercept represents intercept and axis. The slope and intercept used to measure the average rate and change in the linear relation between strength and age of the cement for our sample. So for this relationship, we can conclude that if the steepness of the slope is more, then the stronger the cement. But if the age, but with a lower age or time, and same with the vice versa version. So that's all for me. Thank you.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Hazid bin Muhammad Anwar Zamani. My meeting number is AE190027. Okay, I will present for the task F, G, H, and I. Okay, for the F, we refer to the table 4.2.6 and 4.27. This one. And for beta 1 is equal to 1. Okay, from the t-test using the tail of test alpha is equal 0.05, and v equal to n minus 2 equals to 98. Thus t average equal to t 0.05 98 equal to 1.6606. Okay, we get this value is from t distribution table. Okay, the decision rule: reject if fall in the t-test rejection region. TC is greater than 1.6606 from the compute t-test equal to negative 35.0785. Okay, for the G question, we refer again to this table, and for beta 1 is equal 0 from the t-test using the tail test alpha equal 0.05 and v equal 9 minus 2 equal 98. Thus t average equal to t 0.0598 and equal 1.6606. We get also we get this value is from the t distribution table. Okay, for the decision rule, reject if fall in the t-test rejection region. TC is greater than 1.6606. Okay, from the compute t-test equal to 3.83409. Okay. Okay, for the coefficient, this is table 4.2.8 is a coefficient summary of the sample. Okay, for the H question, the coefficient of Pearson correlation based on the table 4.2.8 is referred to the multiple R used to measure strength and direction of linear relationship between two variables. Coefficient of Pearson correlation is equal 0.36067. Thus, the value of R is greater than 0 and smaller than 0.36067. Correlation is negatively weak. Linear relationship between strength and age. Okay, for last question is I. The coefficient of determinant known as R square, which used for determine how much variance for strength can be accounted for by age. Okay, the coefficient of determination is equal 0.13008, and thus the coefficient of determine equal to R square multiplied by 100% is equal 0.13008 multiplied by 100%, and then we get 13% of the variance in variable age can be accounted for by the strength measure. Okay, that's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. So this is discussion for the project based on our experiment result about set of 100 data of strengths by age of concrete. The actual independent and dependent variables of concrete analyzed are explained. An experimental result we got by use of Microsoft Excel software we compare to the theoretical values. We know that age flow through from time to time without being disturbed because its value is independent of other variables in our data. While strength is the most important asset for manufacturing and it always depends on the change or material in the mixture based on the certain ratio. As we can see from the result, the mean of variable age per day is 40.81, while for variable strength for MPa is 34.059. Next, from 100 set of data, we can see the standard deviation value of variable age per day is 50.83658, while for variable strength for MPa is 13.8691135. Then for independent variable of age, the minimum value is 3 while maximum value is 365. Next, the minimum and the maximum value for dependent variables of strength are 4.9 and 71.3 respectively. From the graph, we can see that the test finding reveal that the core compressive strength of concrete grows with age, but it is somewhat more than 50-day cube compressive strength even up to 100 days in moderate concrete, whereas the core compressive strength remains lower than 50-day cube compressive strength. Next, for the conclusion, and to summarize our experiment result about set of 100 data of strength by age of concrete, we know that when age of concrete increase, so strength of concrete increase but by the time it will remain the strength or will be decreased depend on another variable. It because the hydration happens more quickly in the early phase following concrete placement and the slow down after a month or two. Simply said, when the concrete cures and hydrates, it becomes stronger and hydration can continue long after the minimum needed compressive strength has been achieved. So from the project, we know that independent variable and dependent variables of set of data will determine mean, standard deviation, minimum and maximum values. So that's all from our group. Thank you.